Today we're reasoning through the impact of aircraft landing gear configurations and aircraft weight on airport planning and design without hesitation, repetition, or deviation starting now. The configuration of an aircraft's landing gear and its weight are critical factors that significantly influence airport planning and design. These elements determine the strength, durability, and layout of pavements, taxiways, and runways. Aircraft landing gear configurations come in three primary types. Number one, the single wheel configuration, where there is one wheel per strut used mainly on smaller aircraft. Then we have the dual wheel configuration, where there are two wheels per strut offering better weight distribution, which is typical for larger commercial aircraft. Lastly, we have the dual-tandem configuration, where there are two sets of wheels on each strut supporting the heaviest aircraft by distributing weight more evenly across a larger area. These basic configurations provide foundational designs, but larger aircraft have more complex systems. For example, the Boeing 747 uses a combination of dual and dual-tandem gear, also known as the double dual-tandem. The Boeing 777 uses triple-tandem gear, and the Airbus A380 features a mixture of dual-tandem and triple-tandem configurations. These intricate landing gear arrangements are crucial for distributing the immense weight of these aircraft across multiple points on the ground, preventing pavement damage and ensuring safe landings and takeoffs. The number of wheels in a landing gear configuration directly affects the design and strength of airport pavements. The heavier aircraft require thicker, more durable pavements to support their weight during taxiing, takeoff, and landing. For example, the dual-tandem and triple-tandem configurations seen on wide-body aircraft spread the weight more evenly, allowing pavements to bear heavier loads without suffering structural damage. This means that runways, taxiways, and aprons must be designed with sufficient strength to handle the weight distribution of modern aircraft, particularly as they get larger and heavier. Aircraft weight is another major factor in airport design affecting the strength and layout of various airfield services. Several key weight measurements are crucial. First up is the operating empty weight, or OEW, which is the aircraft's weight including the crew and necessary equipment, but without fuel or payload. OEW is essential for designing hangars, maintenance areas, and parking stands where the aircraft may be stationed without a full load. The zero fuel weight, ZFW, is the weight of the aircraft including payload but excluding fuel. This is used for planning areas that must support fully loaded aircraft. The maximum ramp weight, or MRW, is the maximum weight an aircraft can have while taxiing on the ground, including fuel for engine run-up and taxiing. Pavement design must account for MRW to ensure surfaces can support aircraft as they maneuver between gates and runways. The maximum structural takeoff weight, or MSTOW, is the maximum weight an aircraft can have at the point of takeoff, including fuel, payload, and equipment. This weight is the most critical for runway design, as the runway must be able to withstand the stress of the fully loaded aircraft during acceleration. The maximum structural landing weight, MLW, is the maximum weight the aircraft landing gear can support during landing. Aircraft typically burn off fuel during a flight, so their landing weight is lower than the takeoff weight, reducing stress on runways during landing. It must be noted that if an emergency occurs mid-flight or right after takeoff, pilots must ensure that the MLW is not exceeded before landing at an alternate airport or returning to the origin airport. Aircraft weight fluctuates depending on fuel consumption, payload, and environmental conditions such as altitude and temperature. High elevations and warmer temperatures reduce engine performance and may limit the weight at which an aircraft can safely take off. These factors must be considered when designing airport infrastructure, especially runways, which must accommodate the maximum takeoff and landing weights under various conditions. When planning airport facilities, engineers must ensure that runways, taxiways, and aprons can support the specific landing gear configurations and weight profiles of aircraft that will use the airport. Large aircraft like the Airbus A380 with its dual and triple tandem gear require thicker and more durable surfaces. Taxiway and runway widths must also be adjusted to allow for increased turning radii associated with larger aircraft and their complex gear systems. In conclusion, the interplay between landing gear configurations and aircraft weight is crucial in airport planning. The design of pavements, runways, and taxiways must accommodate these factors to ensure safe, efficient operations for all types of aircraft, from smaller jets to the largest commercial airplanes.
If you like this video, don't forget to hit the like button, leave your thoughts in the comments, and subscribe for more aviation content.